We're going to do a little rundown on the beginning of how to set up Lewis structures. I'll read the first 6 steps, and then we'll do a couple of examples to kind of see how all the steps work. So the first step is you need to look at your atom and decide which piece of the atom is bound to each other. So if you had an SO3, you'd want to look at the sulfur and the 3 oxygens, and we'll do that example in a minute. The next thing you'll do is refer to your periodic table and count all your valence electrons that you're going to have to find places for. The third step, you will place 2 electrons in each bond around whatever you've decided your central atom should be. The fourth step, you'll complete the octets on all of your exterior atoms. And the fifth step, we'll take any extras, see if we can complete the octet on the central atom. And then lastly, if it turns out we don't have the octet, we'll do some double or triple bonds as needed and create an octet. Okay, our first example, we're going to do the atom SO3. So, since you've got 1 sulfur and 3 oxygen, that's going to imply that your sulfur needs to be your central atom. So this would be the best guess on whatever setup you want to use. So we'll start with that. The next step we're going to do is refer to the periodic table and see how many valence electrons we're going to have to put in here. So we have 1 sulfur, and sulfur is a 6A on the periodic table, so now we have 6 electrons for it. We've got 3 oxygen. It is also a 6A element, so we're going to have 6 electrons for each one of those, so that's going to be times 3. So I have 18 here, 6 here. Going to have to try to find a place for 24 electrons altogether. So now we've decided this is our best setup. We know how many electrons we've got, 24. Now we'll start placing them in. The next step, that should be number 3, 2 electrons on each of our central bonds. That used up 6. So now I have 18 left. The next step, build the octets on the exteriors. So there's an octet here, and an octet there. So I've used 6, 12, 18, which is exactly how many I had left. The problem now is I have no electrons left, and I'm still missing an octet on my sulfur atom. So it doesn't matter which oxygen you pick. We're going to pick this one, move this here to create a double bond. So now my ultimate result is going to be my sulfur. I had a single bond here. We left that oxygen alone, so now it has an octet. I had a single bond here. We left this oxygen alone, so now it has an octet. Our shift gives me a double bond on this one, and that's going to give me an octet on everybody. So this one is done. Our next example, we're going to do something that's a little more complicated, not too much. We're going to HClO3. So our first step is do a best guess on what's going to be our central. Now, I have 1 hydrogen, 1 chlorine, 3 oxygen. The 3 oxygen lends itself for those guys to be around the outside, like this. So now I need to determine what's going to be here. Hydrogen only has 1 electron. He's not very good as a central, so we're going to put the chlorine there for our best guess. And now the hydrogen, it'd be pretty easy to stick him here, but that's a no-go. You want to make sure he goes to an oxygen. They like it better. So this is going to be our best guess that we're going to start with. Our next step is to go back to the periodic table and look for our electrons. So I've got 1 hydrogen. He's a 1A, 1 electron. Got 1 chlorine. The chlorine is a 7A, so I have 7 electrons. 3 oxygen, 6A just like before, 6 each. 6 times 3 gives me 18 for a total of, I hope I have it written down, 26. There we go. So 26, we got to find a place for 26 on our basic set here. So we decided we wanted a chlorine in the middle. Oxygen here, oxygen here, oxygen here. Stick the hydrogen out there. We are up to step 3, which is to put electrons in all of our central bonds. So I get 2 here, 2 here, 2 here, and 2 here. So out of my 26, I've used 8 of them. That knocks me down to 18. Next step is to start filling up the octets around the outside. So an octet here, octet here. This guy already has 2, so I just need 4 more. Here's the exception. Hydrogen only has 1, only needs 2. There is no octet for this guy. He's good the way he is. So I've used 2, 4, 6, 8, 10, 12, 14, 16. 2 left, which is perfect. I now have 2 to make a perfect octet around my chlorine, and we're done. Everybody's happy. Normally you would change this and write it as such for a Lewis structure to show that you understand. Let's get everybody in there, that these guys are bonded. And there you go.